Okay, just to summarize so far what we've graphed for y equals ax squared, and then we're always comparing our graphs to the parent graph, y is equal to x squared. So for y equals ax squared, here's what we took a look at first. If a is equal to, a equals 2, and then a equals 1/2. So if a is greater than 1, like 2, it could be 5. I know we didn't take a look at an example like that, but 8, something like that. Then what happens compared to y is equal to x squared is there's a vertical stretch. In other words, again, the graph gets skinnier. So you can kind of think about it as your parabola like this. Let's just say that's a rubber band, and then you can stretch it out vertically. That means top to bottom. That's your vertical stretch, specifically by a factor of, again, there's the acronym, but it's always going to be by a factor of a. That's if a is more than 1. Again, as an example, y is equal to 2x squared, or y equals 5x squared. A is 5. That's more than 1. It could also be something like y equals, 3.5x squared, or 7/2 x squared. And then what happened if a is less than 1, but more than 0, like 1/2? And there's going to be a vertical shrink. Or in other words, the graph gets like wider, and specifically by a factor of, again, it would be a. So there's a vertical shrink by a factor of 1/2 on the example that we went over. That's an example where a is less than 1 and then more than 0, so y equals 1/2 x squared. It could be something like this: y equals 1/3 x squared, y is equal to 2/7 x squared, and so on. The vertex is still at 0, 0. The axis of symmetry is still the y-axis, or at x is equal to 0.